Electrifying a moving vanity drawer to keep a hairdryer plugged in often violates several electrical codes. The National Electrical Code, or NEC, Section 400.14 states that electrical wiring must be securely fastened and not subject to movement. This is often violated when wires move with the drawer. NEC Section 404.10 requires that electrical boxes be securely fastened to a structural member. A moving drawer is not a structural member, and this would be a violation. NEC Section 406.9 states that electrical conductors must be protected against physical damage. Wiring in a moving drawer is subject to physical damage due to movement. To create a moving electrified drawer, flexible conduit might be used. Flexible conduit is sometimes used to connect electrical wiring to moving parts because it allows for movement. A slip ring is sometimes employed, which is a rotating electrical contact that allows electrical power to be transferred from a stationary part, such as the vanity, to a rotating part, like the drawer. To bring such an installation into code compliance, several steps can be taken. Firstly, securely fasten the electrical wiring. The flexible conduit and slip ring should be securely fastened to the vanity and drawer to prevent movement. Secondly, install a dedicated electrical outlet. It would be wise to install a dedicated electrical outlet inside the drawer to avoid the use of an extension cord. Thirdly, use a code-compliant cord. If an extension cord is necessary, use a heavy-duty cord that is rated for the power consumption of the hairdryer. Fourthly, ensure the wiring is protected. All wiring should be protected from physical damage by using conduit or other appropriate methods. Additional considerations include fire hazards. Electrical wiring that is not properly protected can create a fire hazard. Another consideration is shock hazards. Moving electrified drawers can increase the risk of electrical shock. Property owners and contractors can be held liable for electrical code violations that result in injury or property damage. This is a significant liability issue. The following is a detailed discussion of the code sections and considerations. NEC 400.14 addresses the proper use of flexible cords and cables. It specifically focuses on ensuring that these cords are used in a manner that prevents damage and maintains electrical safety. This section prohibits the use of flexible cords and cables as a substitute for the fixed wiring of a structure, meaning you cannot use extension cords or similar flexible wiring as permanent wiring solutions. Flexible cords and cables should not be run through holes in walls, ceilings, or floors. This is to prevent physical damage to the cord, which could lead to electrical hazards. Flexible cords and cables should not be run through doorways, windows, or similar openings. This is to prevent the cord from being pinched or damaged by the opening and closing of these structures. Flexible cords and cables should not be attached to building surfaces. This prevents strain on the cord and reduces the risk of damage. Flexible cords and cables must be protected from physical damage. This can be achieved through various methods, such as using conduit or other protective coverings. NEC 404.10 focuses on the proper installation and support of switch boxes. Switch boxes must be securely mounted to a structural surface. This provides stability and prevents the box from moving or becoming dislodged, which could compromise the electrical connections within. Switch boxes must be rigidly supported. This ensures that the box can withstand the weight of the devices and wiring connected to it, as well as any physical stress it may encounter. The support must be independent of the surface finish. This means that the box should be supported by the structural elements of the building, not just the drywall or other finishing materials. Switch boxes must be mounted flush with the finished surface. This prevents gaps or openings around the box, which could allow access to live electrical parts or create a fire hazard. In damp or wet locations, switch boxes must be approved for the environment. This ensures that the box is protected from moisture, which could cause corrosion and electrical faults. NEC 406.9 outlines the requirements for the protection of receptacles. Receptacles must be protected from physical damage. This can be achieved through various methods, such as using recessed receptacles, installing protective covers, or locating receptacles in areas where they are less likely to be damaged. Receptacles in damp or wet locations must be protected by an enclosure that is weatherproof when the receptacle is not in use. This prevents water from entering the receptacle and causing electrical faults. Receptacles installed in countertops must be located so that they are not subject to physical damage. This can be achieved by recessing the receptacle or providing a protective barrier. Receptacles must be grounded. This provides a path for fault current to flow back to the source, which helps to protect against electrical shock. Receptacles must be installed in accordance with the manufacturer's instructions. This ensures that the receptacle is installed correctly and safely. Flexible conduit, often liquid-type flexible metal conduit or LFMC, is a type of electrical conduit used to protect insulated electrical conductors from impact, abrasion, and moisture. It is commonly used in situations where flexibility is needed, such as connecting motors or other equipment that vibrates or moves. It is suitable for use in both dry and wet locations. It provides a degree of mechanical protection to the conductors inside. It allows for flexibility in wiring, making it easier to route wires around obstacles. A slip ring, also known as a rotary electrical joint, is an electromechanical device that allows the transmission of electrical power and signals from a stationary to a rotating structure. It consists of a stationary brush or contact that slides along a rotating ring. The ring is connected to the rotating structure, and the brush is connected to the stationary structure. Slip rings are used in a variety of applications where it is necessary to transmit power or signals to a rotating component. They allow for continuous rotation without twisting or damaging the wires. They can transmit both power and signals. They are available in a variety of sizes and configurations. When considering code compliance, all the electrical work must comply with the applicable electrical codes, such as the NEC. Electrical installations must be inspected and approved by a qualified electrical inspector. Ensure that all electrical components are properly grounded. Use appropriate wiring methods for the location and application. Protect wiring from physical damage. Fire hazards can arise from overloaded circuits, loose connections, damaged insulation, and improper use of extension cords. To mitigate fire hazards, install smoke detectors. Do not overload circuits. Replace damaged wiring and electrical components. Use extension cords safely. Shock hazards can arise from contact with live electrical parts, damaged insulation, and improper grounding. To prevent shock hazards, avoid contact with live electrical parts. Repair or replace damaged insulation. Ensure that all electrical equipment is properly grounded. Use ground fault circuit interrupters or GFCIs in wet locations. Property owners and contractors can be held liable for electrical code violations that result in injury or property damage. It is important to ensure that all electrical work is performed by qualified electricians and that it complies with the applicable electrical codes. Obtain necessary permits and inspections. Maintain records of all electrical work. Carry adequate liability insurance. In the context of the Electrified vanity drawer, several potential issues could arise. The repeated movement of the drawer could cause wear and tear on the wiring, leading to damaged insulation and potential short circuits. If the wiring is not properly secured, it could become pinched or tangled, creating a fire hazard. The use of extension cords inside the drawer could also pose a fire hazard if the cord is overloaded or damaged. The close proximity of electrical components to water in the bathroom could increase the risk of electric shock. To address these issues, it is crucial to ensure that the wiring is properly installed and protected. Flexible conduit can be used to protect the wiring from physical damage, and strain relief fittings can be used to prevent the wiring from being pulled or strained. The wiring should be securely fastened to the drawer and vanity to prevent movement. A dedicated electrical outlet should be installed inside the drawer to avoid the use of extension cords. GFCIs should be installed to protect against electric shock. Regular inspections of the electrical system are also essential to identify and address any potential problems before they become hazardous. Property owners should be aware of the potential risks associated with electrified vanity draws and take steps to ensure that their electrical systems are safe and compliant with electrical codes.